Okay, so we've got day 2 of 3-2 notes today. So this is day 2, and what we're going to be looking at is some calculator use. But the first thing I need from you is make sure you have a calculator out, and we'll start manipulating some stuff for this. I'm bringing back logistic functions because I'm going to start today with logistic, and if we have time, I'm going to end today with logistic. Okay? Gosh, it kind of makes me think I have a quiz coming up that has logistic functions on it. But, you know, that's next week. Find the logistic function that satisfies the given condition. Use the model below to get started. But now here's the deal. This is the thing I get a kick out of. We just grab this model, and I say initial height. Okay? Yet we don't know what the model's from, you know? So I don't want to talk about it as initial height. Let's just talk about this as initial value, okay? Because that should save some stuff. What I want you to be aware of when we talk about a logistic function, you can be given some basic stuff and able to find the remainder of the pieces of the function itself. But you need initial value. You need like to limit the growth. That's our C value. And remember, half of our C value, our C over 2 is our inflection point. That's where the function is growing the fastest for logistics. And we did this not yesterday, but the day before. But when we're talking about this, once I give you information in a basic formula, you can fill in the rest using algebra. So let's talk about what I know about some things. But first, let's find A. So I'm going to look at my function probably with finding A. And I got my function. I'm told C is 30, so I've got that there. So I got 1 plus A bx. Now, in doing this, I've got to recognize that my initial value, 5, is when x is 0. Does that make sense? My initial value, or my y-intercept, is when x is 0. So now my b to the 0 is 1. So I've got 5 is equal to 30 over 1 plus a. Okay? Are we okay where I'm getting a versus a times b to something? Because b to the 0 is 1. Now, I multiply both sides by 1 plus a. So I got 5, 1 plus a equal 30. I divide both sides by 5 and find out that 1 plus a is 6. And consequently, a is 5. Happy coincidence on this problem that a is 5 and my initial value is 5. It just happened that that was the case. It's not always the case, okay? Now, a is 5. So now I know that a is 5. I'm going to find b, but I'm going to plug in the fact now, as I know things, I have a is 5. I am looking for b. I have another piece of information in this function, or at least in the problem, to help me find this function, that passing through the point 3, 15. 3 is x, 15 is my result, my y value. So 15, or my f of 3, is 15, and I have 30 over 1 plus 5, b to the 3rd power. Okay, where I put in the 3 and my x just to make sure, hey, you know, I've got to find my b value. I'm going to work this thing to solve for b cubed. Okay, so I'm going to multiply both sides by 1 plus 5b cubed. Both sides. Okay, so 15, 1 plus 5b cubed equals 30. Now I'm going to make it easy on myself. I am not going to distribute the 15. I'm just going to divide by 15. 15 goes in the 30 evenly, and it gets that out of my way. So now I've got 1 plus 5b cubed equals 2. I'm going to subtract 1, and 5b cubed equals 1. b cubed equals a fifth. And consequently, I'm looking at the fact that b is just 1/5 to the 1/3 power. If I take the cubic root of both sides. Are we okay with the manipulation algebraically? Stuff that totally algebra students would be able to do, expo students be able to do. You guys did as algebra 2 students. Okay. really want to make sure that a miracle doesn't happen. There shouldn't be a miracle step. You shouldn't start at 15 equals 30 over 1 plus, the quantity 5 plus b cubed, and then come up with the final answer. I want to see the steps. I want to see the evolution of your solution. Okay, wasn't intended to rhyme that way, but it came out nice. But now I was supposed to find my function. My function, keep in mind, f of x, 30 on top, 1 plus my a I found 5. I now have b, and I could put this 1/5 to the 1/3 power into my calculator and round it to a certain number. It's like 0.5 something something something, but I really want to have it as a fraction in there. Okay, I want to have all that value in my function. So I'm going to leave it as 1/5 x third power. Now, this freaks some people out, but keep in mind, I was supposed to raise b to the x power, and x times a third is x thirds. Okay, so I have that, and now I can put that in, and I won't lose anything in my value as I walk through it. Are there any questions? Doing okay? I was asked to find the function, the logistic function, based on the information I had, and that's the bad boy I'm supposed to find. Now, grab your calculator. Ladies and gentlemen, turn your calculators on and go to your stat list area. Hit your stat plot button. This is taking a little time to get there. I'm not sure why it's taking so long. Hey, cool. So in your year, when we're using this next one, we're using regression models to help us, okay? So this is all calculator functionality. Calculator would let your finger do the walking. It'll be a snap. Use 1900 to 2000 data in table 3.9. That's this table. And an exponential regression. Please notice I'm using exponential regression here to predict the US population for 2007. Compare the result with the listed value of 2007. Okay? So here's the thing. If I'm going to use this to predict the population for 2007, don't enter the population value when we get to 2007. Just kind of do the first 10 or 11. Don't put 2007 301.6 million in the list that you're making. But I would like this to be in list 1 and list 2. Okay, as you put them in. And remember, since 1900, 1900 is 0, and you're working up 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And I've got to fix mine because I think I was just quickly entering things, and I put in 2007, and I got to delete those. Good. Okay. Okay, good. You saw it, right? It was just not working the way I thought it would, but just because it doesn't work that way doesn't mean I'm right, it's wrong. It's more like it's right, I'm wrong. Get your list in there, and we're going to talk about setting it up. By the way, these other lists in our next problem, we're going to use L3, L4, L5, but when we get there, it'll be easier for you guys to enter them in. Anybody having any issues with entering stuff, finding what's going on, or follow-up questions on why in the world, Bloom, do you want to just enter everything but 2007? Okay, keep in mind, I'm checking to see if the population value of 2007 is predictable. So I don't want to put that and have it influence how I find my function to make the prediction. Otherwise, oh boy, it really works really well. Okay, so be careful about that. Now, I've got L1, L2. We were told in the problem further up here that I'm using the exponential regression model. So I'm going to use the exponential regression, and now I've got my L1 and L2. They're in there. My X is always my years. So now I hit my second quit and second. Well, let me get rid of some stuff. I'm going to delete some stuff. Second clear. Where is that? Yeah. So now I'm going to go into my, I got to go back to stats. Sorry, guys. And I'm in the calc because that's where my regressions are. And I want to go the exponential regression, and that's down further. Forgot which one, otherwise I just pushed the button. Okay, so it's my 0, so 10. You guys got yours at 0 too? Good. Now, when I enter that, L1 was my X, L2 is my Y. I want to store this, okay, because I might want to use it later. I'm not going to use my frequency list, but I am going to use store my regression equation in Y1. So hit your vars, go to Y vars, and function, and Y1. And now all I have to do left is just calculate. So you all okay with this? Now, anybody with the old school calculator that doesn't have it set up that way, that is still wondering how I would set it up? You're doing okay? Now, I've got this list. Now remember, I've got 80 in that, but I want to go back to my list for a second. I got 0 to 100. That's my X's. Okay, and I want to predict 2007, so I got to go 0 to like 130 for my X's. And my Y's are going to be anywhere from 0 to 300, or actually 350 because I'm supposed to go 301.6. So when I go in here and I go to my stat, I could go to my Zoom standard, not standard, where's my Zoom stat 9? And hopefully they'll come in. And I've got that going. I don't even think I had it plot anything, so that's my bad. So, oops, let's go back here. I gotta go to a plot. I gotta turn it on. And I already got it set up. So now I go back to graph. So I'm gonna go to Zoom stat. And now that's there, it'll pop up. And there's my curve, kind of. Okay. Oops. Kind of makes me think that I screwed up on one of my numbers, doesn't it? Okay, let's go back and check that number. So yeah, that 20.3. What is the number opposite 70? 200 what? 208? Two. Wow, really? God, how did I screw that up? Anyways, I'm not surprised. Okay, 203. And thanks for your patience with me. Okay, 203.3. That one's in there. All right, good. Now we go back to everything that we just did. So I've got to catch up to where you guys are at now, as always. You guys are way ahead of me. So that was a 0. And my vars Y1. And calculate. So now that should be okay there. And we should be able to graph. Whew. Boy, that's so much nicer. No, you okay with what we've got? Yes. Under your catalog, you'll want to put diagnostics on. Okay, and we can do that after the problem real easy. We'll just look it up under D in your catalog and go to diagnostic on, hit enter again, it'll turn it on, it'll show those R values. Okay. So this fits pretty nice, right? And as we go, if we wanted to, we could actually go to the table and, excuse me, where's my table value? Second table. Somebody's got to push in the right buttons. And I'm just going to go out as I go through here. You know, this is kind of going slow, so let's go to that table change. Second table set, I think that's it. I want to start my table at 2007 because I'm just going to go right there and check it out. But I don't want to do it that way. I want to go 107 because we started at 0. Okay, so now we hit enter and we go second table. And now we add 107. Right now we're predicting the population to be 317 million something, 40,000. Okay, does that make sense? And are you okay with how I got there real quick? Okay, using my table set. You want to see that again? Okay, so under my table, I'm allowed to adjust my tables, and I can start my X value on my table wherever I wanna. Okay, so I put that in, and I can even go up my table. I can go up by 7s, I can go up by 8s, I can go up by 0.0001s. By the way, if you do that, it takes forever to get to 107, so just fully know that that's the case if that's gonna happen for you. So if you're cursoring through, there's a faster way to do it. So now that we've got the table adjustment going, I go back to my table, and now I'm looking at, in year 2007, I should be predicting 317 million, okay? In this graph listed, we have 301.6 million. So when we're doing this, we've got this information. By the way, this is my Y1. This stuff is, but according to this model, the population of the US for 2007 is 317 million. The actual population was 301.6. Our model was off by 5.1%. We had a 7-year happening there. Something happened at 2000, okay, that prevented our model to get to that extra 10 million people in the population. And you can speculate what it was. You can look at some other data and see what it was. But for right now, the only thing we've got is there's a difference from our model. Okay, so it's a little off from what the actual would have predicted for whatever reason. Okay. I've had students make other predictions. What happened in 2001? 9/11. So some people last year said, well, 9/11 happened, so, people weren't as forthright bringing other people into the world. They didn't have the want to have a family and be exposing them to whatever, but there's other things that play in with it, I'm sure. Okay, so let's keep that in mind as we're going. We don't have the whole picture just with this, but there is something going on. Okay. Are there any questions about what we did, how we did the work with the calculator or anything like that with the regression model? And let me tell you, this calculator totally rocks because when I was you, we didn't have anything like this. We had to do it by hand. So consequently, it was either one problem for the entire period or we just did other simpler stuff and it didn't extend to what we would actually do in the real world to predict stuff. Okay, so let's go on to this next one. Next problem. In this next table, oh my gosh, it's after 1800, in this next table, I've got to fix mine. For some reason, I wasn't too careful about watching this stuff. So in the next table, since we already have L1, L2, make this one L3, L4, L5, okay? And as you enter them, we're going to be looking at logistic functions, and we're going to use the limit to growth regression model, okay? And we're going to compare populations of Florida and populations of Pennsylvania. Now you got to keep in mind, Pennsylvania as a state's been around for a long time population-wise, because it's one of the ones that were first settled, versus Florida. Florida has not been around as much, but Pennsylvania was kind of established. Okay, as we look at the population, and since 1900, and Florida was 500,000 and Pennsylvania was 6.3 million. Okay, so keep that in mind as we're entering, but they want us to talk about the population of Florida and Pennsylvania respectively in years since 1800. And because of that, if you guys would enter those in that way, I've got to fix mine, so I'm going to fix it back at my desk. It'll be faster, okay, than doing it up on the board. No, I got it. It's 100. Okay, fixed. So we got those done. I know you're all shocked that I got it fixed that fast, but that thing up there is really slow compared to what I can do at the desk. All right, so when we're looking at this with my population, as I just cursor through to make sure I didn't screw up any fat fingeritis ones like I did in the last one. Okay, looks good. And that looks good. That 5 looks kind of funky. Oh, I just got a 5 in there. There's L4. Yep, 160. All right, cool. So now, are you okay with your L3, L4, and L5? Are they all good? Now, what you're going to do is you're going to set up 2 regression models. Because we're setting up 2 regression models, and we have those other ones in there, and I want to make sure that we're able to access all of them if we want to come back to them or something. So I'm going to, instead of just saying, hey, I'm going to go vars Y1, I'm going to put Florida in vars Y2 and Pennsylvania in vars Y3 in that order, okay, in my calculator. So if I want to go back to it, I can if I want to, okay? So I'm asked to do it as a limit to growth model, okay? We got to find out what that looks like in our calculator. So again, L3 and L4, the years in Florida, L3, L5, Pennsylvania, okay? So I'm going to, in my calculator, I'm going to go to my stat because I want to go to calc and I want to go to, I think it's like 11, but, or A, I think it is. Power regression, logistic. It just says logistic. That's the one we want. We're going to do a logistic model, okay? So hit enter. And remember, it was an L3, so second L3. L3 is my years, L4 is my population value. Second L4. I want to put it in my store. I'm going to hit vars. I want to put it in Y2. Down 1, Y2. Okay, and I'm going to calculate that. Enter. It's trying to think, but nothing happens. This is why I drink coffee, by the way, waiting for the calculator to do stuff. Okay, so that's in there. That's it. I've got it saved. I got to do the same thing with Pennsylvania. So again, I go to stat. Okay, I'm hitting calc. Okay, I'm going to B. Yeah, we're just going to arrow down. That's probably faster here instead of doing the other stuff. I'm going to go to B for logistic. Okay, hit enter. Now I'm going to go L3, L5 because that's the Pennsylvania information. And I'm going to save it in my yvars Y3. So that way I have all 3 of my functions available to me in my graphing area if I want to use them later again. I'm bummed that hit that because I wanted to do that. Okay. Now I've calculated that. Now it's going to take the same amount of time to calculate that. And notice I've got the windows on the bottom of this example 7 in your notes right now. And look how big that window is. They've got it from 90 to 2010 or 210 and -5 to 20. Okay, to see it. So now that I got that up, I'm going to check my window. Okay, so I'm still going to go -10. I like seeing the grids on my graph. My max, I'm going to go out to like, they had 210, right? I'll go 250 just to make it a little bit bigger. My others, I'm no longer am worried about 325 million, okay? In this one, my biggest number for Pennsylvania, or excuse me, for Florida is 16 million. I'll go out to 28 million, okay? So I'm gonna start out at -1 so I can see my grid, and go to, well, 25 million. Sure, why not? And hit enter from my max and graph. And I forgot to select a couple things. So let's go back there for a second, my window. Oh, okay, cool. I'm just go back to my window for a second because I forgot something. X is 250. Yeah, that's good. Y, yeah, I want to get rid of those. I want to make that as, let's go up by 20s, 10s. We'll go up by 10s. That way we can see stuff. So my two graphs that I have on there, the last one I put in there was my Pennsylvania. So this is Pennsylvania's graph. Okay. And that, actually, the first one was Florida. This is Pennsylvania's. Okay, you okay with this so far? Remember, logistic models have that horizontal asymptote of y equals 0, and then they approach the other horizontal asymptote, the limit, okay, their limit to growth. Pennsylvania's already achieved its limit to growth. Yet, although I put in that much larger value of time for Florida, it's not achieved its limit to growth yet. Okay. Matter of fact, what I have on the graph is 2050. So when you guys finally decide to retire, there'll still be room in Florida for you, okay, to go hang out. Okay, that's what we're looking at. Okay, phew. Okay, because it's not until the end of 2000, the end of the 21st century. Okay, so in 2100. Okay, think how old you'll be if you're there. Okay, because you're born at the turn of the century, young whippersnappers. Okay, keep in mind what's going to happen with Florida, or at least the prediction based on its current trends. Okay, so we're looking at this, and what's this graph mean to us? First of all, I did put the graphs in, and I've got that going on. Okay, so we have those. We just saw the pictures of them that Pennsylvania already plateaued. But Florida is, if we keep in mind, still growing, and it's growing nearly at its fastest rate right now. Okay, it's at its inflection point. It's growing as rapidly as possible. A friend of mine lives there. I'm not saying I have really old friends, but I do. A friend of mine lives there, and he was complaining that it seems like there's 1,000 new people here every month that just move into Florida. No, I think he said every day. And I was like, I think you're overestimating, but he could have heard a story, because if we look at this in this 10-year period for Pennsylvania, it just grew by 0.6, 600,000. But in Florida, it grew by 4 million. So it's 500,000 a year. Okay. How's that going to 1,000? I mean, probably, yeah, probably more than 1,000. The amount of people that are moving there every day. It's crazy, okay? But keep in mind what this all means if you are in infrastructure, building roads, bridges, sewers, okay? Fresh water. By the way, the #1 idea that saved millions of lives is indoor plumbing. Okay, because it used to be that all the sewage and everything would lay out in the street, and then when it rained, it would just wash away. Well, all the bacteria that would have been created with that made so many people sick. As soon as we had indoor plumbing, as soon as we have a place where we had a sanitation department, that was like a major discovery of, improvement of life and being able to extend people's lives. But you got to keep in mind as we're looking at that, the two different things. Pennsylvania had rapid growth in the 19th century and the first half of the 20th. And, our graph showed that. And it's now approaching its limit to growth. Okay, so it's tapering off. It's not increasing as much. Florida is currently experiencing extremely rapid growth, but should be approaching its maximum sustainable population by the end of the 21st century. By the time you guys decide, should I retire in Florida? Florida might be, the town that is Atlantis. I don't know, it might be underwater at that time with the rising sea levels. Okay, but we'll see. Questions about how I'm looking at that stuff. Infrastructure changes. This is a graph that if I was planning, looking at all sorts of housing and zoning and everything, I'd be looking at to see, okay, what do we got to plan for? That's why we have a census every 10 years to plan for infrastructure changes, to get more money from the federal government and state governments in order for us to go to that next step, okay, whatever that might be. And by the way, it's based on a best guess estimate. So that's why we always have bottlenecks in areas, because they probably didn't foresee that in the general plan. And then all of a sudden, for some reason, that was the place that everybody wanted to be. So then they'd have to change things. Okay, so logistic models, pretty darn fun though. Next, other logistic models. In example 3, the bacteria cannot continue to grow exponentially forever because they cannot grow beyond the confines of the petri dish. In example 7, through Florida's population is booming now, it will eventually level off, okay, just as Pennsylvania's has done. Sunflowers and many other plants grow to natural heights following a logistic pattern. Chemical acid-based titration curves are logistic. Yeast cultures grow logistically. Contagious diseases, even rumors spread according to a logistic model, okay, which is very interesting because they're like living, breathing organisms. Rumors, okay. Watonga High School, I just like saying that, Watonga, it's got to be someplace in Wisconsin, right? High school has 1,200 students. Bob, Carol, Ted, and Alice started a rumor, okay, which spreads logistically according to that function, S of T. Okay, that models the number of students who have heard the rumor by the end of day T. Okay, so there's a couple of things I know. How many students have heard the rumor by the end of day 0? I just put 0 in for my T value. Okay, at time 0, how many people know the rumor? Okay, so my evaluation here, I put in 0, so it's e to the 0 power. So really I'm taking 1,200 and dividing it by 40. Okay. So that should be 30 people have heard the rumor. It's probably some team or some class. Hey, we're getting out. Who's heard that one? Did you hear we're getting out? It's snowing out, and a middle school teacher goes to you, we're getting out. Yeah, we will eventually at the regular time every day, 2:10. Okay, but you tell a middle school kid when it's snowing out that we're getting out, and automatically the buses have been set by the district office, we're going home. Okay, that's the rumor that was. If I started it in my room and I was that teacher, I'd go, hey, did you hear we're getting out? And I always say it to a staff member, kind of like I'm telling them a secret, and they start shaking their head. Bloom, I don't want to hear this in my class later. And it's like, oh, don't worry, you will. Okay, so immediately it just like spreads. Less than an hour, I'm being told by students, okay, that weren't in my previous class, boom, we're getting out. And yeah, I know that. I started that rumor. And they're like, no, it's not. It's the truth. My mom and dad called. I was like, whatever. Okay. But remember, it's a rumor. It's a living, breathing organism. So we got 30 people that learned it. So 30 students heard the rumor by the end of day 0. How long does it take for 1,000 students to hear the rumor? Now, again, at this point, I've got to be talking about, I want to know 1,000 students have heard the rumor. And we learned yesterday that I can take and put this in my calculator. I can say, hey, this is Y1 and this is Y2. Okay, splitting the equal sign apart, finding where they cross. I can tell you how many people have heard that rumor, or what day I should say that people have heard that rumor. Okay, 1,000 people have heard it. But in this one, I'm going to solve it. Okay, so when I'm solving this, I'm going to kind of do some stuff a little quick. And the reason on this is just to save room and to let you guys realize how I look at these. Did you know that I'm going to be looking at this as this is 1,000 times this and 1 times 1,200? I could do a cross multiplication. But have you noticed that whenever I have like things that are done like this, if I have time equals distance divided by rate, couldn't I have rate equals distance divided by time? You guys worked with that, right? If I flip-flop that, that's why I'm about to do what I'm going to do. I can do this really quick, okay? Because I've done this enough that that bottom one on the right would go into position on the left and they'd flip-flop. I could show that, hey, I'm going to multiply both sides and then divide, but I'm just saving myself time because if time is equal to distance divided by rate, rate is equal to distance divided by time. See how fast I flipped them? But we're all accepting of that. It's the same move here, okay? So now I've got 1,200 divided by 1,000, which is 1.2, or 0.12. And yeah, 1.2, yeah, sorry. And then I'm here, I'm just gonna subtract 1, okay? So I'm gonna subtract 1, so I got 0.2. And I'm gonna divide by 39, okay? I'm getting it whittled away so I can get to my e to the negative 0.9x. Okay, so I'm at this point, and I'm going to take the natural log of both sides. You did this last year. Not sure if you're feeling real confident with it. So on a confidence level, how you guys doing on these? Being able to take the natural log of both sides. I got some thumbs up, I got some thumbs sideways. I got some people looking at me like, are you freaking kidding me, Bloom? It's Friday, I don't want to go through this. So here's the thing. What's the natural log do? When I do this, if I do it to the natural log of the same base of what I'm doing here, I'm asking you to come up with the power. Notice how I said that. The power that I'm taking the base e, the natural log, is asking what power would I take base e to get e to the negative 0.9x power? Well, it's negative 0.9x. If I was doing just on a side, the log of 100 is asking you what power do I put 10 to come up with 100? And you're like, well, 10 to the second power, so it's 2. This returns 2. Okay, if I did log base 10, remember it's base 10, of 10 to the second power, I would say, well, that returns 2. That's why I can say I'm returning that value here in this next one. Okay, I'm just going over a property of logarithms and natural logarithms. Some of you knew it, but you got to keep in mind it's asking me about a power. Okay, and what I would put that base, what power I put that base to achieve the number that I'm taking the natural log or common log of. Now, at this point, I've got x on the main line, and I can solve as normal. Okay, so I have this in my calculator, the natural log 0.2 divided by 39, right, parenthesis and everything, make sure you put it in that way. I'm dividing that value by negative 0.9. What I need you to do is get that in your calculator and make sure you can come up with the same answer I do. Okay, because part of this is not just doing it or figuring out that we can do it, but to experience it and know that you can do it. Okay, so it should take 5.859 days for 1,000 students to hear this rumor. That's a lot of Facebook chatting, you know. And by the way, I think with Facebook, it would spread faster. And because of that, you got to be thinking about the news life. You know, like I'll have a student tell me something in the news and I read it last night because the news cycle is so short now. It used to be, well, you know, you got the morning news, you got the evening news, and that's when you found out your information. Now with the, you know, when you first had CNN and ESPN, we had news 24/7, but not everybody had those cables channels. Now with your cell phone, I've got a news feed that comes up with new stories whenever they come out. It pops up on my phone all the time. It's buzzing in my pocket. I'm like, okay, I gotta quiet this. But I can read a story and make it by the end of the day seems like it happened last week and it just happened today because I'll have read that many stories about the entire situation and I could just read headlines. It's happening so fast now that I would be interested to see what a logistic function is with the idea of Facebook, you know, Instagram and everything involved and how quick they can spread and infect, you know, others. It's an interesting thing. But with this stuff, the way we're doing it, keep in mind, I did mention that we could put this in Y1, Y2, and this is where I would do it and how I'd get it done for my table set. And I could do that. Okay. Graphing calculator and solving. Remember, this is the solving algebraic support of your answer versus graphing calculator part of your answer. Okay. Are there any questions about approaching those? Probably one of the funnest problems. Okay. For me, maybe I like this stuff because I didn't do this a lot when I was you guys because we couldn't. Okay. This is really a lot of fun to look into these. We've got another logistic problem I want you guys to do, but that next one, I want you to try it on your own. I've got the solution, but we've already done one. We did one 2 days ago and 3-1 day 2, and I want you to practice one today, right now. So look it over, and in 5 minutes, I will get the first A, B, and C out. Okay, it should go pretty quick. It should take about 5 to 6 minutes to do. Okay, I've already got it set, and I just want to make sure that we're comfortable doing it. And the page that it's on the previous stuff, so you can refer, just to make sure that you have a chance to look at a model of it, I believe it's on page 10. Page 10 in your notes is the first time you saw it, right after logistics functions. Okay, it's almost the same problem. I changed the logistic function. So give it a try if you want an example. If you want to run the numbers when it happened in day 1, day 2, day 3, go ahead and put it into your calculator. Since now we've used Y1, Y2, and Y3, put it into as Y4, and then you can like run it through, and I'll do that so to give you an example. It really does. What did you do? It's all fracked up. Really? Will it do that even though it shows that it's slanted there? Okay. All right. I'm loving that. I'm loving that. Thanks for pointing it out. But I bet the CE, because the older ones probably wouldn't have it. But I'll look. I'll check that. We're talking about fraction setup in your function, so you have a horizontal bar versus that slanted thing that's really hard to deal with. I like the fraction bar, so it's more of a grouping symbol. Yeah, see the one I've got, I don't have the fraction possibility. Yeah, the older ones don't. That's a newer one. We talked about that fraction bar, the horizontals being there. So you've got the new and improved one. You're a kid with all the money in the block. You probably use your iPhone for a doorstop. Let me see if I can get this up as well. Okay, so the first thing I did, I put this in my Y4 in my calculator, and they're asking me how many students on campus were originally affected at the end of day 3, day 10. And so I've got this, and I'm just going to double check to make sure I put in the right stuff, because otherwise, I'm going to go, hey, look, ta-da, and I'm wrong. But here it works. So now this is in Y4. So now I'm going to hit my second quit, and now I'm going to go to my vars, and I'm going to open up Y4. It's kind of a pain in the butt this first time, but now that it's out, I'm going to put in my left parenthesis and put in 0. And I know people are like, well, dude, it's easy, it's 0. But check it out, that's 2.2. And now I hit my second enter, it brings everything back. And I'm going to change that 0 to 10. And it gives me my other value. It's that fast, okay? So I have my 0 and my 10. And what else? At the end of day 3 and end of day 10, I got my end of day 10, so like 6 people, and I forgot about day 3, so I'm gonna pop in and put that 3 in there now. And delete that. I'll put in my day 3. And hit enter there, and that evaluates there. So that's my A. Are you okay with my A values? Any questions about what I do? My 0, my 10, and my 3. Okay. Now, the next one was how many days have 10 students been infected? Now, with Y being 10, I can totally go to my table in my calculator. So I go to a second table, and I want to know 10. Oops, I've got to go back a little bit because I adjust my table. Hey, I'm going to put in at 10. Okay, that's the thing I'm worried about. Let's see if that'll let me do that. Nope, I have the wrong function up there. No, I do. I have that one. So I got my second, my table, and I'm looking at 10. That's 5.9. But now they're asking, when will 10 kids be infected? So it's going to be between 15 and 16. Okay. You see that at day 15, I got 9.82. So if I just use my table, I've got this. I can break down my table without even doing my algebra, and I can set that up going by my table start. I'm going to start it at 15. Okay, and I'm going to go up by 0.01s. Okay, I already know the answer, by the way. I did that algebraically. So now I'm going to hit enter, and now I'm going to go back to my table, second table, and now I can just go up the 17 spots that I need to go to find exactly 10. Oop, right there. I just went a little far. So my 17 at 15.17 something something something. That's when at least 10 students have heard my rumor. Well, that's B, okay? Are you all right with my answers for A and B? In C, we're talking about 1100 for this. Guess what I'm going to change in there? I can put in 1100 and come up with my table and do it that way, or I can continue and do what I did here and do it algebraically. I got those, and here it is in C, got 1100, and I solved it algebraically to get 69 days is fastest rate. Why is 1100 the fastest rate? Because that's the inflection point. Half of my limit to growth here is 2200. Half of 2200 is 1100, and I've got it made. Okay, that's what I do with that. Okay, now according to the model, after how many days will the entire student population become infected, and how can you tell? Now, the entire student population will not be totally infected, but it'll approach, the model predicts that over time, the number infected only approaches 2200. The graph of the model is an HA, that's Y equals 2200. So the entire population will never be infected. There's always somebody that doesn't get it. There's always somebody that licks the ground, literally doesn't wash their hands, eats everything else, and nothing, okay? And there are other people who take care of doing everything and they're sick all the time, and I feel sorry for them, okay? We've got to get going. We'll talk about the last answer tomorrow. But thank you for your time today, you guys. Have a super day. And enjoy your weekend. I'll just flash that up just in case you guys did it. Just in case you did it, I'll flash that up.